Hello, my name is Goran Begic, and be your presenter today. The topic of this webinar is RASP Adoption, a view from the trenches. Over the course of the year, together with my team, I've done a number of evaluations and early adoptions of the RASP technology, and I want to give you an update on what lies ahead and give you some tips and suggestions on how to do effective onboarding of runtime application self-protection. Here's my contact info. I'm the Vice President of Product at Immunio. I'd like to mention that this presentation is general about RASP. We will talk, I will introduce the company, and you may see some screenshots, but in general, the core of this presentation is vendor agnostic. You can contact me directly via chat during the webinar, or you can send me a tweet or just drop your email in the webinar contact. I can send you a copy of the presentation and we can connect on a number of issues. Some of my favorite topics relate to application security, but also product management, customer success, innovation, SaaS in B2B, and so on. In the past, I worked with static analysis at Veracode and in general in other technologies for software development, testing, and application security. About Immunio. Immunio is the innovator in the RASP space, founded in 2013, headquartered in Montreal, Canada. You can see some of the customers and early adopters who we worked with, but there's naturally many more. And this is really the core competence of the organization is RASP. So what is RASP? What is Runtime Application Self-Protection? Well, first of all, there is the acronym. It is really a concept where protection of the application, protection of the integrity of the application, and sensitive data can be integrated inside the application. We'll talk about how that technology works, but really fundamental difference from, for example, web application firewalls is that protection lives and inside the application, travels with the application, and so on. So it's protection from inside. It's also all about prevention of exploitation. What I mean by that is that there are other technologies that aim at finding issues before going in production. RASP is all about protection in production, and so there are certainly some implications that I want to talk about in this presentation. RASP is also a group of technologies. It's not necessarily one technology, and all this really leads to a number of tips and evaluation criteria and some suggestions for better adoption that I want to share with you through today in this webinar, and also give you some tips on how to inquire about certain aspects of RASP. At the beginning, it may all look very complex, like that big rock that you see on the slide, but I'm sure over the course of the presentation, everything will make a little bit more sense. All right. So the term itself was coined by Gartner, the analyst company, and Gartner also recognizes runtime application self-protection as transformational. I want to mention that often you may hear terms about RASP technology. Really, in reality, there is a number of vendors that have different products that focus on different feature sets and use cases. And really, there is a number of different technologies that are being used to deliver protection inside the application. It is still very much early days, but as you will hear, there's also some very, very good successes with adoption of RASP. It's certainly sort of the way of the future. Now, these technologies, they vary, and so I'll just mention sort of 4 concepts that you will also see as you start engaging with RASP. One is agent-based. That means that there is typically a library or something that's added to the application that becomes it's packaged with the application that provides security services. VM instrumentation, some vendors are approaching RASP through the instrumentation of the virtual machine itself, of the runtime. So they're not attaching to the runtime, they're instrumenting the runtime. Other solutions have a library and API for developers to use, and the actual logic lives outside of the application. And then you will see some sort of technologies that are based on signatures, which means that it is very much a web application firewall approach, but just packaged inside the application. Still RASP, but very, very different technologies. So what does this mean to you? Well, it means that, this is a good question to discuss with your vendor because there are implications. For example, if you take a technology that instruments virtual machine, well, how frequently can the vendor deploy and provide updates to the virtual machine compared to the original? How quickly can you expect support for other languages and so on? Another implication of a technology that uses appliance that's outside of the process of the application is performance. Is that acceptable for your use case and the deployment environment? These are all very, very good questions to discuss with us vendors as you go into, when you start dealing with this new technology. A little bit more about runtime concepts. So if you are like me, who was familiar with static analysis and dynamic scanners, RASP brings a different perspective, brings a new perspective, and I'd just like to clarify that briefly. Well, there's three. You could divide the information into three groups. One, and by the way, I'm not saying that one or the other vendor provides all this information, just that conceptually this type of information is available to RASP, and it's really up to vendors to decide how to implement and use this information. Well, the first is information about the HTTP requests and users who are interacting with the application. Again, we are talking about runtime, we are talking about production. So what are the usernames? What are their IPs or geolocation? And how do these requests look like? So who is interacting with the application? There is a second group of information, and it's really something I want to highlight, which is sort of the runtime data. That's not the same as the source code. It's what the application is actually executing during runtime. What routes are executed, what functions are called, how does the stack trace look like, what is the server response. So there's runtime traces of data as application executes each request that a RASP solution can have access to and use it to make decisions. Then finally, there is the third group of information, which is sort of what was the application designed to do. What are the methods and libraries and source code that it uses? Now, note that this information doesn't tell you how it actually executes, and this is really the key information when we look into application security. Very often, attacks are trying to get the technology to execute something that it wasn't necessarily designed for. And so all these three parts of groups of information together can help you and the RASP tool build a very clear picture as to what's happening during execution of the application. So how is this information being utilized? What features do vendors provide in order to provide help and assistance and prevent exploitation? Well, the first group is probably the most familiar one, which is prevention of code injections, cross-site scripting, directory traversal, fundamentally the runtime portion of the OWASP top 10, the types of code vulnerabilities that are very prevalent and severe. They can be introduced directly through poor coding or through third-party libraries. There's also a certain level of zero-day protection that you will get from some of these RASP solutions, because especially when they are general and the rules and that determine the logic of the solutions are general. They can also protect against 0 days. Another aspect of the application, a lot of attacks and a lot of exploitations start as authenticated users, are run through the authenticated users. So protection of authentication and user accounts can also be improved through RASP. In a way, it can be added to the application. Furthermore, general security intelligence can be collected from the applications and even provide protection against layer 7 DDoS attacks. So in the recent weeks, we've all heard about DDoS at a new scale. They can also be executed on the application layer, and RASP can provide protection. And finally, you can also have RASP solution monitor various different business-specific events that can be integrated in a full picture and detect anomalous use or potential exploitation. So on the business side, what does that mean? How do these features help accomplish business objectives and reduce risk? Well, the first thing is that by providing this protection layer for a potentially vulnerable application, you can instantly reduce risk of exploitation. And I mentioned that a couple of times. That's really, really critical when you look at this technology. It won't remove the vulnerability from the application. If it's poorly coded, it's still poorly coded, but it will prevent exploitation of these vulnerabilities once deployed. And that's really the key. Another use case is there may be applications for which you don't have resources, and you may know that there are vulnerabilities or that there is a potential risk, but there is no time to fix these issues. And RASP can help provide assistance there. And fundamentally, in all mission-critical web applications and web services, this is, in a way, you can see it as the last line of protection that will prevent exploitation. In terms of prevention of authentications and session management services, RASP can help reduce time to detection of stolen accounts. So again, not something that every vendor necessarily provides, but again, the information that RASP has can help address some of these issues. And help add security to DevOps iterations. So what's happening with DevOps is that there are rapid development, test, and release cycles. And traditional application security methods cannot be applied. There's not enough time to do proper testing and assessment. Adding security to the application can reduce the risk in such deployments because this protection layer becomes the part of the application. And then in general terms, if you use sort of systems to collect information from various different aspects of your infrastructure and applications, you can then integrate data and intelligence collected through random application self-protection to form a bigger picture of what's going on in your system. I want to highlight this particular topic because I think it's really critical and important to understand. You may have heard of these acronyms: SAST for static analysis, DAST for dynamic analysis, IST for interactive application security testing, and then RASP. The first three, SAST and DAST and IST, are designed to help find and remediate issues before going in production, fundamentally the purpose of testing. And with RASP, we are really talking about deploying something in the production environment. What this means is that there are really significantly different technology requirements and certain design challenges that are presented to these different solutions. So because runtime application self-protection needs to function in production, you need to take into consideration performance impact, availability and reliability of the service of the application that's being protected, and also protection of data and privacy. Now, these are important elements in the test environment or sort of in a development environment that become critical in production for various different reasons. This also means that your RASP solution needs to be very fast, it needs to be easy to use, and it needs to be very, very reliable. And in a moment, I'll talk about some of the evaluation criteria that are important to consider when dealing with RASP. This also means that, for example, performance requirement means that you may not have the luxury of applying expensive performance and resource expensive data and control flow analysis. The technology needs to make decisions fast and almost in real time. So what are these key evaluation criteria? And I mentioned that earlier that throughout these various different engagements, I've seen patterns, and that was also my instinct initially, was to go and focus on that element of protection and to take a vulnerable application and try to exploit it while having runtime application self-protection providing this protective layer. This is great. This needs to be kind of a part of each evaluation, but it's not all. It is equally important to evaluate the sort of false positive rate, or how the technology responds to valid requests, not to attacks, but how does it respond to valid requests? Does it allow these requests to operate properly? Does it provide the same availability of service? The solution would be very limited if it prevents attacks, but also prevents a significant portion of users from benefiting from the functionality. So when looking into these technologies, it's equally important to be able to verify protection against attacks, but equally so send some good traffic and then monitor how the protective technology interacts with those, because it should just let them execute. And then while this is happening, I want to mention performance, because in some ways it's an obvious topic. In other ways, measuring performance is not always a straightforward exercise. One level of performance is really just comparing the reaction time, the server response time, with and without RASP technology. That's an obvious one. But if you want to go a step further, then you can add certain load to the application, and you will see a different behavior in both cases. So if you're doing performance testing, it may be good to actually plan for both performance analysis without RASP technology, then with RASP technology, and potentially adding additional elements like load testing, stress testing, and sort of detailed distribution of data inside the application, performance data. All this can be combined into one sort of evaluation process that will give you a very good picture of how this technology will perform once you deploy it with your application in production. So we talked about technology and what it does. How does it work once adoption starts? So once you're done with evaluation, what are some of the things or hints that can help you prepare for RASP? Well, the first thing is general awareness about application security. And one way to look at RASP, especially if you have an elaborate program, is that it can add an additional layer of protection to what you already do. But it's also something that, if you haven't really started a project, can be an excellent first step. Some of the things that I've seen very often, some of the questions that are posed by different people involved in the process is like, it has to do with maturity of the technology and business processes. How are we going to use this technology? Is this something that operations team is going to react to, or is this something that we need to monitor from, that is going to be self-sufficient, and then only occasionally we look at trends? So these are the two options. They really depend on the use cases that you decide to use runtime application self-protection for. So one use case is for example, security intelligence, where you may have information about users and events that happen, but not necessarily turn sort of active protection on. So you need to review those events and then make decisions. And in our case, if you set up protections, then you probably need to monitor from time to time to see the trends and perhaps set up limits and alerts that will tell you when something is happening that's outside of the normal range. One important thing I want to mention is roles and responsibilities. And again, this is really important when you consider an evaluation, which is that typically this is a team sport, and adoption and application security is a team sport. So it's really good to discuss the roles, who's going to be engaged. Let's say you have an agent-based solution. It needs to be packaged with the application. It would be good to actually run, this is just like any other third-party component. So it may be good to run a series of functional tests with this third-party component. Then also have an upgrade plan, just like you have for other third-party components. How frequently are you going to update the third-party component, and who is going to do it? It is in one way similar to any other dependencies, and it is different because, you know, the information provided by RASP is probably going to be on top of mind to your application security team. And so you need to discuss, and I'll talk about this, some of the best practices, discuss some of these considerations prior to adoption, because it's going to make everybody's life much easier later on. So what are some of the suggestions on how to make the whole process of evaluation and decision making and adoption much easier? Well, the first one I'd like to suggest is to, and it may be obvious, to have an evaluation plan. That plan can include the criteria, the applications that are going to be involved, the resources, and timeline. A very good reason for that is to also articulate a business problem and share that with all the stakeholders involved in the process. And if you'd like, I can share with you sort of a template. I put together a template so that you can see an example of how the evaluation plan will look like, and you can use it to sort of negotiate that whole process with other people who need to be involved. Let's say you are director of DevOps operation, and you're really interested in embedding security in the DevOps process. Creating a plan, articulating the nature of the problem that you're trying to solve, and then sharing that with the architect of the application or a development lead can be a great way to reach agreement on what is going to be used and how and when. So I mentioned stakeholders. Some typical questions is that can come up is, hey, but we can build something like that ourselves, which is true in some cases, like for example for, let's say, geolocation and monitoring of authentication. Facebook and Google provide such functionality with their popular applications. But it's also something that requires a great deal of expertise. It needs to be done systematically. It cannot be one solution for one application and another for the other. It needs to have a roadmap and a plan for how it's going to keep up with different threats that are not yet known, that are going to be perceived in the future. And so it will require significant knowledge and resources, which may or may not be something that you want to invest yourself. The other approach, and the reason why we exist as a vendor at other vendors, is to help you take advantage of the knowledge accumulated in this technology and help you benefit from it, and sort of also continuously get it improved to keep your application up to the latest standards. Another thing is, we already do static and dynamic scanning. We have web application firewall. Why do we need another solution? So it may depend on the architecture, but as far as you are moving away from the notion of a perimeter as a protection point, if you're dealing, especially web services and mobile in general, and if you're moving into cloud, a perimeter is disappearing as a notion, and you need to think about alternative ways to secure the applications. In some cases, it may not be even possible to deploy a web application firewall. Plus, web application firewalls are also notorious for maintenance and also for a level of support that is required to keep them up to date, because they typically deal with a large number of very specific signatures that need to be continuously updated, and because they don't see and understand the concept of the application execution. So there is actually, I can share at the end of the presentation, there is a very good case study that compares Immunia approach to RASP with some of the leading web application firewall vendors. There are some big differences in terms of performance. RASP, in-process RASP, is actually significantly faster. And then certainly maintenance, because WAF deals with this great number of very specific signature outside of the context of application execution. Then finally, the third part I want to mention is as you're going into the evaluation. So I mentioned the communication with stakeholders, the plan that can help you accomplish certain objectives even before the evaluation starts. And then during and after the evaluation, sharing this information, sharing the knowledge and what you have discovered with the stakeholders will keep them more involved. And certainly, if you can provide feedback to the vendor that you chose to do the evaluation with, that would be very, very helpful, because we are all learning from every new deployment and every new opportunity to engage in protecting applications. So this is all I had for this webinar. I want to thank you for your attention. I want to offer to continue the discussion in the chat. I see that there are some questions. But also, if you would like to discuss RASP, the evaluation process, and adoption of RASP in greater detail, you can just leave me your email or just contact me on Twitter, and I will be more than happy to discuss that with you. So at this point, I'd just like to answer some of the questions. So I see two questions about the presentation and the evaluation plan. I would be more than happy to share that. So if you submit your email in the questions section of the webinar, I'll reply to you, and I'll attach the documents so that you can have them. I have two documents. One is sort of the PowerPoint with the overview of the whole evaluation program. I call it Proof of Value. And the other document is a checklist with all the important milestones and preparation steps. I tried to incorporate, there was another question about the role of RASP versus traditional WAF. I tried to incorporate that question in the previous slide. But again, if you leave your email, I'll send you the case study that goes in great detail. I think that the key point with web application firewalls is that they're disconnected from the application. And it's really, really hard to build very exact signatures that are based on just on traffic of data coming into the application, and then base decisions on whether or not something is an attack and whether or not this attack needs to be prevented. Inside the application, the RASP has much more contextual information about the execution patterns, not just the signatures of the data coming in, but the patterns of behavior of the application. And with this information, it can make a much better decision on when it's being attacked, how severe the attack is, and if the exploitation is going to happen, and then act accordingly. That's really the key difference. Plus, web application firewalls, and I hear that from a lot of people, because they're difficult to maintain, people often run them sort of in a detection mode and don't really even try to take advantage of some protective capabilities because they're so hard and tedious to maintain. Having that contextual information and allowing automation to do that gives an upper hand to RASP. A question about zero-day attacks. So I mentioned zero-day attacks, and again, I'm talking in general. Obviously, I'm much more familiar with the technology from Immunio. So I can give you an example that's very, very specific. So the way Immunio uses agent-based technology, it monitors certain parameters of execution. So let's say if you take SQL injection as an example. SQL injection is an attack where the attacker is able to, by modifying data external to the application, inject a command that will sort of trick the database into serving data that it shouldn't do to this user. And the challenge is that there may be various different ways on how to accomplish that objective. However, if you look inside the application, there is a very clear pattern of what's going on. All these injections are really trying to change the structure of the SQL statement. That's one of the runtime parameters that Immunio uses, for example, is it monitors the structure of the SQL statement. So regardless of how the request looks like, what was the actual sort of semantics of the attack, it can detect the implication, the impact on the application, and you can see that the application in this execution flow is now suddenly significantly different. And instead of using a very typical query structure for that type of for this execution context, it has now suddenly changed it, which represents a signal that that an attack is about to succeed. And this is really where RASP can then act much later in the process by monitoring the actual execution and not just the HTTP request. So what I mean by that, and so just to put it back in the context of zero-day, you may have, 0 days can be found in third-party components. They can be made public, but they come in categories. And so serialization in Java is, for example, a very typical problem. A RASP solution can address a whole categories of 0 days because it's monitoring sort of the impact, not necessarily just the signature. And that allows solutions like that to cover a whole range of 0 days even before they are made public. The other element is some 0 days require a dynamic update, and a lot of RASP solutions actually have the capability to update the logic in order to adjust to the 0 day. So there's certainly not a full coverage of 0 days, but there's a partial coverage, and typically you can ask your vendor to, when there's a major outbreak or major 0 day that is announced, you can ask your vendor to give you guidance and information on whether or not they are already being protected against it. Languages that are supported. There's a question about, okay, so this is RASP technology. What can you expect in terms of the language support? So I think that if you look at the whole space, Java and .NET are typically the languages that most of the vendors support, but certainly you will see RASP solutions for Ruby, for Python, for Node, and I think that all the vendors are trying to cover as much space as possible because in many organizations there is a variety of technologies. So, but I can tell you for sure that if you're looking for RASP, you will find RASP for Java, .NET, Node.js, Ruby, and Python. All these solutions exist today. Right, somebody gave me a thumbs up from the audience. Thank you very much. I appreciate all your questions. If you have any questions that you come up with after the presentation, feel free to contact me directly. I think you have my Twitter sign, or just send me your email. Thank you very much.